Okay, so we're going to go ahead and continue on with some more that are a little more complex. This time they did not set up the graphs for us, so we have to understand how to set up the graphs. So looking at the information, remember your x's are always your numbers on the bottom. So it looks to me like for our x's, we can just do 0 through 5. So 0, 1, 2, 3, 4, and 5. And for our y's, we can go ahead and here they have pi. So 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. Don't worry about the fact that there's a pi there. We're just going to go ahead and put that behind each of them. So I'm going to do each box is worth 2 pi. So this would be 4 pi, 6 pi, 8 pi, and 10 pi. Okay? So now they've already, we don't have to go through and solve anything out. They're just asking us to graph our information. So it says write a linear equation that relates y to x. So we're going to continue what we were doing before. Here they're just giving us a scenario. Then it says what do the variables x and y represent? And graph the linear function. So our x's, if we notice when we look at our picture, what is x representing? That is representing our radius. So I'm just going to go ahead and write next to my graph. And you guys could do it to the left. I'm going to do it to the right just because that's where I have space. I'm going to go ahead and write here that this is representing the radius. Okay. Our y is going to be 2 times pi. So where is that 2 coming into place? If this is x, where is the 2 coming into place? Well, if this was 1, how are we getting 2 pi? We're doing the diameter. So diameter times pi, or pi times diameter would be, that's our circumference. Okay, so that's what each of those is representing. So now we're going to go ahead and graph out our information. So we did, what did the variables represent? Graph the linear function, write the linear function. Okay, so we're going to go ahead and graph it out. So I'm going to go over to 1 up to 2 pi, over to 2 up to 4 pi, over to 3 up to 6 pi, over to 4 up to 8 pi, and over to 5 up to 10 pi. Okay. So now when we write out our equation, well, we've got y equals our slope plus or minus our y-intercept. So if we were to continue this pattern going down, I need to see where it's going to cross the y line. It's going to cross right here. So that's at 0. Okay, so now what is that first part? Well, what's our slope? Our slope is a rise of 2 pi and a run of 1. So this is just going to be 2 pi. Final answer, y equals 2 pi. We don't need to have the 0 at the end. Okay, and we already graphed the linear function. So my question is for this one, could we have it be with a line? Could it be continuous? This would be yes, it could be continuous because we could have x, our domain, could be 1.5. And we could still go through and solve it. We could have 1.5 inches as a radius. So truly and honestly, this should be a continuous line, and it could continue forever in this situation. We don't have to stop just at 5. It's just that that's where we chose to stop. Okay, so when you're graphing these out, you need to write this information in your book, your radius, your circumference, so what your x and y were representing. You need to have your equation, and you need to have your graph filled out. Okay, so quite a few things that you're going through and doing for each of these. Okay, so let's go ahead and try another one. Oops, I'm going to leave that there. Okay, so letter B, we have x of 1, 2, 3, and 4. So our x's are 0, 1, 2, 3, and 4. Our y's are starting at 10 and then going up by 2s. So you can choose, it's probably not best practice to start at 10, and here's why, because we have to see where it actually crosses the y line. So maybe I'm going to go through and do each one worth 2 and see if I can get up to 20, 2, 4, 6, 8, 10, 12, 14, 16. We can kind of go a little off. Okay, 18 would be the next box up. And obviously that bottom line is 0. So now if we go through and we graph this out, I'm going to go over to 1, up to 10. Over to 1, up to 10, put my dot. Okay, so that one's done. Over to 2, up to 12. Over to 2, up to 12. Over to 3, up to 14. Over to 4, up to 16. And then over to 5, up to 18. Okay, we're kind of guesstimating where that 18 would be. So if we go through and write our y-intercept equation, okay, so it's going to, if we continue this pattern, we would go down a box, over a box. It's going to cross at positive 8. So y equals our slope, and it crossed at positive 8. So our slope, well, our rise was 2 between 8 and 10. Our run was worth just 1 here. So it'd be 2 over 1, and that's a positive slope. So it'd be 2x plus 8. There's our equation. Okay, the other thing that we have to do other than graphing it and writing our equation is we have to identify what x and y are. So x, well, what is this? X is our length, or if you put width, that would be okay too. Just depends on how you view the rectangle. And then our y, what would that 10 represent? So if I were to go through, and we'll just use this one as a scenario, if I were to put 1 here where x is, what would 10 represent about this rectangle? So there's really 2 things you can solve on a rectangle, other than the length and the width, and that would be either your perimeter or your area. Well, if you did area, that would be 4 times 1, so it can't be area. Would it be our perimeter? Well, let's check that. 4 plus 4 is 8, 9, 10. That's what it is. So our y is our perimeter. Okay, so my question to you is, now that you know that, could we have our length be in between like 1 and 2? Could our length be 1.5? Yes. So then this would be a continuous graph. So we're going to go ahead and connect this with line. Okay, continuous meaning we could have a number fall between our x's, and yes, we could go through and graph that out. And most of them today that we're doing is going to be considered continuous. I'm just having you understand that concept from yesterday. Okay, letter C. It looks like we've got a complex shape here. So for letter C, we've got our information. It looks like our x's are going 0 through 5. Okay, and our y's are going up by 1, starting at 5. So I'm going to go ahead and do every box worth 1. And we'll have to just guesstimate where 9 is. So if we go through and we graph this, over to 1 up to 5, over to 2 up to 6, over to 3 up to 7, over to 4 up to 8, and over to 5 up to 9. So now we're going to go ahead and continue that pattern. Okay, so we've got y equals something x plus or minus something. So it's crossing at, if we continue the pattern down, it would cross at positive 4. Okay, our slope, our rise was up 1 box, our run was over 1 box, so that would be 1x, or 1 over 1x. Plus 4. So there's our equation. Okay, they also wanted us to go through and identify what our x would represent. Well, our x is representing, it would be what you would call a base, but it would be like your top base. When you work with quadrilaterals, you can go through and use, there's a formula that you can use where you add together your bases, take it times your height, and then divide it by 2. So we're just going to call it a base, even though it's not the bottom. It is one of the 2 bases, one of your top or bottoms. Okay, we're going to call it a base. And for y, that 5, what would that 5 be representing? Well, it couldn't be perimeter, because if it were perimeter, these 2 sides right here are already more than 5. Without the x even involved in there. So if we were to put a 1 in here, what could this possibly be? Well, this is kind of hard because some of you maybe haven't used the formula, but the formula for working with this is to add together your two bases. So if we did 1 plus 4, and we take it times the height, so base plus base, times the height, which, whoops, is 2. And then we divide that by 2, or split it in half. So 1 plus 4 is going to give us 5, times 2 is 10. 10 divided by 2 would give us the 5. This is going to be our area. There is another method of doing it, and you can split it, and lots of times a visual person likes to use that concept of finding the area of the two triangles. But this is just another formula that you can use for a trapezoid to go through and actually find the area of it. So your two units are your base and your area. Okay, so let's go ahead and do another one here. Last one, once again, kind of a complex one, so we'll do it together. And you should be doing all of these in your book. Okay, so here it looks like we have a rectangular prism. So we're either going to be doing surface area or we're going to be doing volume for our y. Okay, so those are the two things that you figure when you have a three-dimensional figure. Okay, so for our x's, we've got 0 through 5. So 0, 1, 2, 3, 4, and 5. And for our y's, we've got 28, 40, 52. It looks like they're going up by, what, 12 every single time? So we could do every box worth 12, maybe? 12, 24. I don't think I'm going to get high enough. 48. Well, we'll try it. So 12, 24, 36, 48, and then 60, 72. Well, that's not going to work. I'm going up by 12s, but I'm not going to land on any of those. So let's just go ahead and do each of these, and we'll just mark them as 28s. I was thinking if I went up by 12s, we would land on those, but there's obviously something in here when we do a plus or minus. So we'll just do every single one worth 10s. Okay, so we're going to go over to 1. Up to 28, over to 1, up to 28, it's going to fall in there somewhere. Over to 2, up to 40. Over to 3, up to 52. Over to 4, up to 64. And then over to 5, up to 76. Okay. So our x's, well, our x's are representing length times width. So I would say that's our width. If you write it as length, that's okay, but your 4 and your x are your length and your width. Okay, so then for y, we're going to plug one of these in. I'm going to go ahead and plug the 1 in just because it's easy to multiply. And we're going to see if this is going to be surface area or volume. So I'm going to check volume first because that's the fastest one to do. So if I were to do volume, 4 times 1 is 4 times 2 would be 8. Our volume would be equal 8. Okay, well, we didn't get 8. We got 28. So this is going to be our surface area because that's the only other thing that we would be figuring when we have a rectangular prism. Okay, so now we have to write our equation. So looking at my graph, it's really kind of hard to see what my slope's going to be. It's also kind of hard to see where it's going to cross my y line. So we're going to go through and we already, oops, I didn't mean to erase that. I'm just going to put SA for surface area. We're going to go through and continue this pattern to see where it would continue working its way through. So if we were to look at this, we noticed that as we looked through these, this was changing by 1 every single time. Our change in our y's and our change in our x's, this was changing by 12. So we're going to go and subtract 12 from this to see where it's actually crossing the y line. So if we subtracted off 12 to see where it would be, that would fall on what, 16? So it's going to fall at 16 somewhere in there. That's our 16. So that's where it's crossing our y-intercept. So y equals, our slope was our rise over our run, which is hard to see on this graph. So our change in our y's is 12 over our change in our x's is 1. So that would just be 12x. And then we just found out by using our change in the y's to see where it actually crossed that it's crossing at a positive 16. So we have y equals 12x plus 16 for our equation. Okay, pretty complex, but it's having you jump back to the things that you learned back in chapters 2 and 3, giving you some real world scenarios. Once again, this could be one that would be continuous. I know I didn't do that on the last one because they could really change. Our x's could be partial x's. They would not have to be exact whole numbers or integers. So that's pretty much it for this lesson, just understanding how to go back and remember how to write a y-intercept equation, trying to make it more real world now.